Welcome to you all. Today's topic is electric field due to an electric dipole at any point on the equatorial line in broadside position. Okay, let us consider an electric dipole consisting of charges plus q and minus q situated at A and B respectively. Let P be a point on the equatorial line at which we determine the field strength. In this figure, AB is the dipole. At A, charge is plus q, at B, charge is minus q. P is a point at which we can find out the net field strength of this dipole. Let 2A the distance between two charges, r is the distance of P from center of the dipole. Okay? Then join AP and BP. Join AP and BP. Okay? In the triangle OAP, AP square, in this figure, AP square is equal to OA square plus OP square. In the triangle, AP square is equal to OP square plus AP square. So, this implies what is AP square? AP square is equal to R square plus A square, R square plus A square. So, what is AP? What is AP? Square root of R square plus A square. In this case, AP is equal to BP. So, AP is equal to BP is equal to the square root of R square plus A square, as AP is equal to BP. Okay. Now, we can find out the field strength at plus q and minus q. Plus q and minus q. Field strength at P produced by plus q. Field strength at P produced by plus q. That is E1. E1 is equal to 1 by 4 pi epsilon naught q by P square along PC. Along PC. Okay. Along PC. Like this, E2. Field strength at P produced by minus q. That is E2. E2 is equal to 1 by 4 pi epsilon naught q by BP square along PB. Along PB. That is equal to 1 by 4 pi epsilon naught q by R square plus A square along PB. So, E1 is equal to E2, but direction is different. E1 is along PC, E2 is along PB. Okay. Then resolving E1 and E2 into their rectangular components, we get, that is component of E1, that is E1 cos theta, E1 sin theta. E1 cos theta along PF, E1 sin theta along PD. E1 cos theta along PF, that is horizontal components, horizontal towards E1 cos theta towards left along PF. ED, that is E1 sin theta along PD. Then component of E2, E2 cos theta along PF, E2 sin theta along PD. E2 cos theta is horizontal component, E2 sin theta along PO it is vertically downward. E1 sin theta along PD, that is vertically upward, E2 sin theta along PO vertically downward. This is clearly in this figure. So, PF E1 cos theta and E2 cos theta along PF, E1 sin theta along PD, E2 sin theta along PO. So, E1 sin theta and E2 sin theta, these two are equal but opposite. So equal and opposite to each other. So these two components are neutralized and cancelled. And net field strength is E1 cos theta and plus E2 cos theta along PF. Okay. So it can be observed that the components E1 sin theta along PD and E2 sin theta along PO are equal and opposite to each other, so they neutralized. Then what is the net field strength? So net field strength at P due to the dipole. What is this? Then the net field strength at P due to the dipole E is equal to E1 cos theta plus E2 cos theta along PF. E1 and E2 are same. So that is equal to 1 by 4 pi epsilon naught Q by R square plus A square cos theta plus 1 by 4 pi epsilon naught Q by R square plus A square cos theta along PF. That is equal to 2 into 1 by 4 pi epsilon naught Q by R square plus A square cos theta along PF. Now in this figure we clearly know that in the triangle OAP, what is cos theta? Cos theta is equal to OA by AP. What is OA? That is A. AP square root of R square plus A square. So in this triangle AOP, in the triangle AOP, cos theta is equal to OA by AP, that is equal to A by square root of R square plus A square. From equation 1, that is E is equal to 2 into 1 by 4 pi epsilon naught Q by R square plus A square cos theta. In this equation, we put the value of cos theta. Okay. So that is E is equal to 2 into 1 by 4 pi epsilon naught Q by R square plus A square into A by R root over of R square plus A square along PF. That is equal to 1 by 4 pi epsilon naught 2AQ by R square plus A square to the power 1 plus 1 by 2 along PF. What is 1 plus 1 by 2? That is equal to 3 by 2. So E is equal to 1 by 4 pi epsilon naught P by R square plus A square to the power 3 by 2 along PF. So what is P? P is equal to dipole moment of the dipole. Okay. In case of dipole, in this case, E is equal to 1 by 4 pi epsilon naught P by R square plus A square to the power 3 by 2 along PF. In case of dipole, A square can be neglected as compared to R square, as A is very small. A is very small. So neglecting A square, we can find out E is equal to 1 by 4 pi epsilon naught P by IRQ along PF. P by RQ along PF. Okay. So this is the total net intensity in case of a dipole of a point, if this point is situated on the equatorial line, that is E is equal to 1 by 4 pi epsilon naught P by RQ along PF. Thank you. That's it.